Hi students, in this video we're going to do trigonometry. The topics involved are bearing, sine rule, cosine rule, and finding area of a triangle. Do get ready a pen and some papers and practice along with me. Supposing I have a cube mouse where I'm going to label it as point M. And what goes along with the cube mouse? Of course, a cube cat where I'm going to label it as point C. I'm going to draw a line from M to C. Supposing C is on the bearing of 120 degrees from M, then how do I measure 120 degrees? The keyword to look out for is this word from. And then we'll take the letter after the word from, which in this case here is the letter M. So at M, we'll draw the north direction. And for simplicity of calculation, we always draw the north direction as vertically upwards as shown on the diagram. And the bearing is always measured from the north direction in a clockwise direction. So that is 120 degrees. All right, supposing I have another cute animal, a bird, which I'm going to label it as point B. And the bearing of C from B is 0.25 degrees. So as mentioned earlier on, the keyword is from, and look out for the letter after from. So at point B, we're going to draw the north direction. And yes, before we do that, we will need to draw a line that connects B and C. And that angle will be 25 degrees. So in summary, bearing is always measured in a clockwise direction. If you're not too sure how the clockwise direction looks like, if you have a analog clock at home, see the directions of your hour hand and the minute hand, that will be in the clockwise direction. It's always measured in the clockwise direction from the north, and the bearing it's always three digits and 1 decimal place if the answer is not exact. For example, if the bearing is 23 degrees, you will have to add a 0 in front to make it 3 digits. And if it's not the exact value, like for example 126.123456, then you express it to 1 decimal place, which is 126.1 degree, or 345 degrees, which is exact 3 digit, or 016.2 degrees, etc. All right, I'm going to extend this question to using the sine rule. So how do I extend it? Supposing the bearing of B from M is 195 degrees. Recall that the keyword is the word from, and then look out for the letter after the word from. In this case here is the letter M, and therefore at M we draw the north direction, which is actually drawn for you. Okay, so the bearing is always measured from the north direction in a clockwise direction. So from here to here, it has to be 195. And since I've already got 120 here, so that explains 195 minus 120 to give me 75, and that explains this angle here. So supposing I'm given the distance BC to be 5 kilometers, and I'm asked to find the distance BC. So how do I go about doing it? Yes, we need to form the particular angle there, angle MBC. So how do we go about finding this angle? Yes, we can find this angle here using angle at the point, taking 360 minus 120 minus 75 to get the angle that's labeled on the diagram 165. And if you were to recall, we have this angle property called the interior angle, where angle A plus angle B will give you 180 degrees. That's called interior angle, right? So from there, I'll be able to find this small little angle here. which give me 15 degrees. And having found that, I can just take 25 degrees minus 15 to find my angle MBC. And why is finding MBC helps us to find distance BC? Yes, using angle MBC and angle BMC, I can use sine rule to help us find the length BC. So what is sine rule? Right, so it can be sine of angle A opposite over the opposite sides equals to sine of another angle B over the opposite side. So we're going to label. It's important that you do the labeling so that you can do the correct substitution. So we're going to label angle MBC as A, and angle is always labeled using uppercase. The sides, okay, MC is the sides, is labeled as lowercase a. And we're going to label 75 degrees as the angle B, and opposite sides is called lowercase b. And to help you remember, it will be good that you just draw an arrow. You see the angle A, the opposite side is MC. For angle B, the opposite side is BC. So that substitute in the values for angle A and angle B. The side A, which is given to be 5 kilometers, and BC is unknown. So let's do a cross multiply. So that will give us BC sine 10 equals to 5 times sine 75. Let's divide by sine 10 on both sides. So that gives us BC to be 27.8 kilometers. Right, let's look at a examination questions. All right, so we have 3 points here, point A, B, and C. A ship sails 185 kilometers on a bearing of 040 degrees from A to B. So if you look at the diagram, the letters after the word from is A. So you see that at point A, we have the north direction drawn. So it's measured in a clockwise direction from the north. So therefore, this is 40 degrees. And it then sails 232 kilometers on a bearing of 125 degrees from B to C. From B to C. Okay, right. So the bearing of C from B, right, you see that the north direction is drawn at point B. The angle is measured in a clockwise direction, 125 degrees, at the distance of 232. And we asked to show that the angle ABC, this particular angle here, it's 95 degrees. Right. So when you're dealing questions regarding bearing, interior angle is a very, very popular angle property that we'll be using. Okay, a lot of times we'll be using interior angle. And interior angle, you just look up for two parallel lines, so that these two angles add up will be 180. That's called interior angle. Okay, right. So what I'm going to do is I'm going to extend the line, the north direction that passes at point B longer. And you will be able to use alternate angle. Oh, yes, another very popular angle property will be using the alternate angle. Look out for the Z sign. These two angles will be the same, alternate angle. Right. So therefore, you will see that, oh yes, of course, since this is a straight line, we can just use 180 minus 25 to get 55. And then alternate angle to get the other angle to be 40. All right. And so therefore, angle ABC will just be 40 plus 55. Just need to show that it's 40 plus 55, give you 95 degrees shown. All right, so how do we calculate the distance AC? All right, so this is where we will have to use this thing called the cosine rule. So what is cosine rule? Right, so basically cosine rule is c squared equals to a squared plus b squared minus 2ab cosine c. So let's label all the three sides. Let's label the angle ABC as angle C. So the side that's opposite ABC will be lowercase c. And then let's label AB as angle A, BC as C. Right. So this will be your angle B. This will be your angle A. Okay. Right. So we're going to substitute in the value for C, which is the side AC. And then for side A will be 185 squared. For B will be 232 squared. Minus 2 times 185 times 323 times cosine. The angle C is 40 plus 55, that's 95. Right, so basically you can just use your calculator to work out this whole chunk of thing. 185 squared plus 232 squared minus 2 times 185 times 223 times cosine 95. And you see that you would get 95530.449. So to find AC, you basically just square root both sides. So that explains how I get this value there. And approximate it to three significant figure, which is 309 kilometers. So that's for part B. So for part C, we asked to calculate the bearing of A from C. So the keywords, the letter after the word from is C. So let's draw the north direction at point C. Right, so the bearing is measured from north in the clockwise direction. Yeah, so that is 55. Why is that 55? Because you will have this parallel to each other, so we can just use alternate angle. So that's 55. And we just mentioned that bearing is measured in a, yes, draw a line from A to C, and it's measured in the clockwise direction from the north direction. So that is the angle we need to find. That will be the bearing of A from C. Right, so but before we can find the angle, we will need to find BCA. Okay, we need to find this particular angle BCA. Right. So what we're going to use? Yes, we're going to use sine rule. Okay. Right, we do a cross multiply again. Divide by 309.08 on both sides. And sine inverse, to find the angle A is sine inverse of 0.5963. That gives us 36.6 degree. So therefore, your bearing of A from C will be 360 degrees minus 55 minus 36.6. That gives us 268.4 degrees. 3 digit and 1 decimal place. All right, let's do another question. In this question here, we're given a triangular field PQR on the horizontal ground, given some dimensions for PQ, PR, and QR. We asked to calculate angle PQR. Okay, so if you look at this diagram here, we are not given any angle, but we're given all the three sides. So we will have to use the cosine rule. So before we use the cosine rule, we're going to let angle PQR be angle C. All right, so that we can label all the sides and the angle appropriately. Label the sides, that's B is opposite uppercase B, and then lowercase a is opposite the angle A, lowercase c is opposite the angle C. So let's write down the cosine formula. That's plug in the value for A, B, and C. All right, so you need to watch out for this. Okay, you can't just use a calculator to work out all these things straight away. Why you cannot? Because if you look at the second part, we have an unknown here, cosine C. All right, so you cannot use the calculator to work out everything at one shot. So how do we do it? Yes, you can use a calculator to work out these two first, because basically they are just numbers. And you can also use the calculator to work out that. So using the calculator for 12.3 squared plus 6.5 squared, you would get, okay, you will get 193.54. So this will give you 193.64. And the 2 times 12.3 times 6.5 will give you 159.9 times cosine C. Cosine C is unknown, so you just have to, you can't do anything with it, just leave it there. And 8.2 squared is 67.24. So the next step is that we're going to minus 193.54 on both sides. So that will give us So when I minus 193.54, this will be gone. And 67.24 minus 193.54, that will give us negative 126.3. Okay, beware that the negative here must continue writing. And then the next thing is divide by negative 159.9 on both sides. And that gives us cosine C to be that, and C is cosine inverse of this value, which is 37.82, round up to 37.8 degrees. So therefore the angle PQR is 37.8. Right, so in part 2 of the questions, you are told that at point P is on the level ground, and then there's a vertical post, okay, something that stick out from the ground. Something that stick out from the ground, all right, and it's 3.7 meter, and you're actually standing at point R. That is you standing here, and you look up, okay, at the vertical post, and you're asked to find the angle of elevations from the top of the post. So this is how you look like. We have a post there, vertical post, height of 3.7 meter, okay, and then you're standing at point R, you're looking up. So the angle of elevation is the one that label it there, called alpha, and you'll see that this is 90 degrees. Why 90? Because anything that stick up from the ground will make 90 degrees with the level ground, okay? Right, so in this case here, you know, let the angle of elevations of the top of the post from R be alpha, yes, okay? So we will have 3.7 as opposite your alpha, that's opposite sides. And then we have PR that's adjacent. So we for a right angle triangle, we can use Stochastic. And since we know O, we know A, we can use tangent. So tangent alpha is equals to 3.7 over 8.2. So alpha will be tangent inverse that value that give us 24.29. Round up to one decimal place, 24.3 degrees. So the angle of elevations of the top of the post from R is 24.3. Right, so for the last part of the question, supposing us to find the area of this triangle PQR, so what formula can we use? Yes, we can use this formula called half AB sine C. So what is half AB sine C? Supposing you have a triangle, okay, and if you know this is angle A, this will be, the opposite side is lowercase a, right? So the other two sides will be B and C, right? So the area of this triangle will be half BC sine A. So supposing in this triangle, you don't know angle A, but you know angle B, and you know this, the other two sides. So it will be half AC sine B. So you see that all the three letters will be used up. Okay, B and C are the sides. And then the angle A is the angle. So ABC. So here, ACB. So supposing you don't know angle A, don't know angle B, but you know this angle C. So the opposite side is letter C. So the other two sides will be A and B, right? So this will be half AB and then sine C. Okay, so ABC, ACB, BCA. Okay, right. So here we already found angle PQR, which is 37.82. So I'm going to label it as angle C. So the other two sides will be A and B, right? So we can use half AB sine C here. So that substitute in for the side A 6.5, side B 12.3, angle C will be 37.82. So you use a calculator, you work out the area to be 24.5 meters squared. All right, so that's all for this video. Happy learning.